Good evening, children.
Good evening.
Good evening.
Good evening, ma'am.
Good evening. Can I see you all? Yes, the others. Please turn on your videos, children. As it is, I'm late. Kindly turn on your videos, all of you. Yes, others. Priyanka. Keep it on, children. Hitesh, Meera. Murali Krishna. Pranav. Sashmin. Shreyas. Children, you have to keep your videos on throughout the meeting. Yeah, I would like to discuss this answer again, children. We'll just see this again. Or let me try to get the answer from somebody here. Yes, we have already seen this question earlier in the class. Let's construct the equations. When the question involves speed, distance, and time, what do we assume? Distance and time. What is x? What is y?
Speed is x and time is y, ma'am.
Yeah, speed. Let's take the speed as x kilometers per hour and time as y hours. What's the distance then?
X into y, ma'am.
Speed into time. Speed x into time y. X, y hours. X, y hours. Very good. So what's the equation in the first case? What is the actual speed?
X, ma'am.
What's the reduced speed? Yes, class, what's the reduced speed? What's a new speed? New reduced speed.
4/5x, ma'am.
4/5 of the original speed. So 4x by 5 or 4 by 5x. All right. So this distance of 30 kilometers is covered with the usual speed or reduced speed? 30 kilometers is covered with the usual speed or reduced speed?
Usual speed, ma'am.
What is the total distance?
30 kilometers, ma'am.
What is the total distance? What is the total distance? XY kilometers. The total distance is XY kilometers. Yes or no, class?
Yes, ma'am. Yes, ma'am.
The total distance is xy kilometers. So what will be the remaining distance? What will be the remaining distance? After covering 30 kilometers, what will be the remaining distance?
XY minus 30 kilometers.
Xy minus 30 kilometers. So 30 kilometers is covered with what speed? X kilometers per hour. And the remaining xy minus 30 kilometers is covered at a speed of 4x or 4 by 5x kilometers per hour, correct? 30 kilometers per hour is covered at this speed, x kilometers per hour. The remaining distance, xy minus 30, is covered with a speed of 4 by 5x kilometers per hour. The first 30 kilometers, speed x kilometers per hour. The remaining xy minus 30 kilometers. The remaining xy minus 30 kilometers. Speed 4 by 5x kilometers per hour. The equation is time taken to cover the first 30 kilometers plus the time taken to cover the remaining xy minus 30 kilometers is equal to the total time taken. The total time taken is equal to the total time taken. The time taken to cover the first 30 kilometers plus the time taken to cover the remaining xy minus 30 kilometers is equal to the total time taken. So how do we find time? Distance by speed plus time is distance by speed is equal to the total time taken. Total time is the actual time taken is y hours plus 45 minutes. The actual time taken is y hours plus 45 minutes because delay, 45 minutes delay. And since it's minutes, you need to convert it to hours. So divide by 60. Y hours plus 45 by 60 hours. So distance 30 kilometers, speed x kilometers per hour, distance by speed plus distance xy minus 30, speed 4 by 5x. So distance by speed plus distance by speed is equal to the total time. So distance by speed is time. This one is also time. The total time is y plus 3 by 4. So this is how you construct the equation. In the second case, what distance is covered? What distance is covered at x kilometers per hour, the usual speed? The second case. In the second case, what distance is covered in the usual speed? Yes, children? Yes, children, in the second case, what distance is covered at the usual speed?
48 kilometers, ma'am.
48 kilometers. 48, who said that?
Sneha, ma'am.
Yeah, 48 kilometers. Usual speed x kilometers per hour. What's the remaining distance?
XY.
Yes, louder.
xy minus 48.
Xy minus 48. What is the reduced speed? Four by 5x. Four by 5x is the reduced speed. What's the total time taken? It was earlier delayed by 45 minutes. Now it reaches 9 minutes earlier. That means the delay is only by 36 minutes. 45 minus 9, 36 minutes. Because when the speed reduces, the train cannot reach its destination on time. Because the speed is reduced. So it cannot reach on time. It will be late. In the first case, it's late by 45 minutes. In the second case, it reaches 9 minutes earlier, which means earlier than 45 minutes. So 45 minus 9, 36 minutes. The delay is only by 36 minutes. So the total time taken in the second case is the actual time y plus 36 minutes. 36 by 60. Because you need to convert it to hours. And construct the equation the way we did in case 1. Time taken to cover the, just divide. This will be time taken. Distance by speed. Distance by speed is a time taken. Just divide these two. 48 by x plus xy minus 48 by 4 by 5x. Distance by speed. This is the distance. Distance by speed is time taken. Distance 48. Speed x plus distance is the remaining distance. Speed 4 by 5x. So this will be the total time taken. This is the time taken to cover the first 48 kilometers. This is the time taken to cover the remaining distance. First 48 kilometers, usual speed, x kilometers per hour. Remaining distance, reduced speed. So the total time, so this is time taken, this is also time taken. So the total time taken is the actual time taken, y hours, plus the delay, 36 minutes. But this is in minutes, so you need to divide by 60 to convert it to hours. So this will be the second equation. We need to solve the two equations and find the values of x and y, and hence find the speed and the distance. Yeah. We finished this in the last class. Let me just repeat this. So the sum of two numbers is 8, and the sum of their reciprocals is 8 by 15. So I was telling you in the last class that when you take the LCM, you get y plus x in the numerator. You need to substitute that with 8 because x plus y is 8. So you get 8 by xy is equal to 8 by 15. 8 cancels and xy is equal to 15. On cross multiplying, you get xy is equal to 15. So what I was telling you is this identity has three expressions: x plus y, x minus y, xy. It has three expressions. Now, we know the values of two of them. We know the value of x plus y. We know the value of xy. So using this identity, you can find the value of x minus y. X minus y. So substitute, use this identity and substitute the known values. X plus y we know, xy we know. And find the value of x minus y. So since it's x minus y the whole square, so x minus y will be square root of 4, which is plus or minus 2. So you get two equations. X minus y is plus 2, x minus y is minus 2. We already have equation 1. Now we have 2 and 3. You know you should not solve 2 and 3. You should not solve 2 and 3. Because they are from the same information. From this one equation, you're getting these two. It's on the same information. You're not supposed to solve these two. So solve equation 1 and 2, 1 and 3, and find the two numbers. So when you have, so we have got another linear equation. So what have we got here? We have one linear equation in x and y. So now we got another linear equation in x and y. So now we can solve these equations. We can solve these equations and find the values of x and y. So this identity is very useful. We finished this one. We have to start this.
Yes, ma'am.
Yeah. The difference of two numbers is 4. And the difference of their reciprocals is 4 by 21. Okay, so again, let the two numbers be x and y. The difference of two numbers is 4. So whenever we deal with difference, we'll make it very clear. Let's see, when it is sum, you don't have to use these words. When it is difference, please be specific in your assumption. You say let the greater number be. Let the greater number be whatever, x or y, whatever. So say the greater number is x and the smaller number is y. That is, be specific in your assumption. When you have this word difference in the question, when it is about difference, let's be very specific in the assumption. Let the greater number be x. Let the smaller number be y. See here, we didn't say that. We just said let one number be x, let the other number be y. Because it's sum of the numbers, sum. When it is difference, you be very clear. Let the greater number be x, let the smaller number be y. Let the greater number be x, let the smaller number be y. So the difference of two numbers is 4. So that means x minus y is equal to 4. The greater number minus the smaller number is 4. The greater number x minus the smaller number y is equal to 4. The greater number x minus the smaller number y is equal to 4. And the difference of their reciprocals is 4 by 21. This is very important. So now supposing now supposing two numbers, 2 and 4. Which is greater? 2 or 4, which is greater?
4, ma'am.
4 is greater. Now when you compare the reciprocals, what is the reciprocal of 2?
1 by 2.
1 by 2. What's the reciprocal of 4?
1 by 4.
1 by 4. Which is greater? 1 by 2 or 1 by 4?
1 by 2.
1 by 2 is greater. But between 2 and 4, which is greater?
4.
Then is the reciprocal 1 by 4 greater now? No. So using this example, you can understand that 2 is less than 4. But 1 by 2 will be greater than 1 by 4. Is less than 4. But when you compare their reciprocals, it's true always. I took 2 and 4 because you will understand half and 1 by 4. Half and quarter we can understand. So I took 2 and 4. Now like 8 is less than 7. Oh, sorry. 8 is less than 9. But 1 by 8 will be greater than 1 by 9. 1 by 8 is greater than 1 by 9. So what have we understood? 2, 4. 2 is less than 4. But 1 by 2 is greater than 1 by 4. Similarly, here x is greater than y, but 1 by x will be less than 1 by y. We need to understand this. I'm just waiting for you to process it. 2 is less than 4. Reciprocals,
Yes,
1 by 2, 1 by 4. Very good. 2 is less than 4, but when you compare the reciprocals, 1 by 2 and 1 by 4, 1 by 2 is greater than 1 by 4. Similarly, x is greater than y, but when you compare the reciprocals, 1 by x will be less than 1 by y. That means 1 by y will be greater. Here, x is greater, but when you compare the reciprocals, 1 by y will be greater. All right. And the difference of the reciprocals is 4 by 21. So the reciprocal of x is 1 by x. The reciprocal of y is 1 by y. Now, actually, x is greater, but 1 by x will be smaller than 1 by y. It will be extensional. X is greater, but the reciprocal will be smaller than the reciprocal of y. So when you write the difference of the reciprocals, you should write the greater one first. The difference of the reciprocals is 4 by 21. You must write the greater one first. 1 by y minus 1 by x is equal to 4 by 21. Yes, Harini?
ma'am.
Yes, Harini?
Ma'am, I just said the answer, ma'am.
Oh, okay, good. All right. 1 by y minus 1 by x is equal to 4 by 21. Let's do it again. So the greater number is x, the smaller number is y. But when you compare the reciprocals 1 by x and 1 by y, x is greater, but here this is small, this is big. So the first equation, difference of the numbers, the first one, the difference between the two numbers is 4. So x minus y is equal to 4. The difference of the reciprocals is 4 by 21. 1 by y minus 1 by x. Difference means minus. The bigger one, 1 by y minus 1 by x is equal to 4 by 21. These are the two equations. So like the earlier one, like the first one, we use the identity to get the other equation in x and y, other linear equation in x and y. So see here, this is the first equation. X minus y is equal to 4. Then you can see here difference of the reciprocals. 1 by y minus 1 by x is 4 by 21. LCM, xy is LCM. So you'll get x minus y. Children, x minus y. On taking the LCM, you get xy is the common denominator. So you'll get x minus y is equal to 4 by 21. And what is x minus y? What's the value of x minus y? 4. X minus y is 4. So 4 by xy is equal to 4 by 21. 4 gets cancelled. So cross multiply, xy is equal to 21. Xy is equal to 21. So the thing is, you have one equation, one linear equation in x and y. This one is not linear in x and y. You cannot like solve these two equations. You cannot write them one below, like you cannot write them one below the other like this and solve it, right? So you're looking for another linear equation in x and y. You are looking for another linear equation in x and y. You want to write them like this. You want to write the linear equations like this below and solve. So to get the other linear equation in x and y, we make use of this identity. X plus y the whole square minus x minus y the whole square is equal to 4xy. So substitute, you know the value of x minus y. X minus y. You know the value of xy. So on solving this, I'll give you some time to go through the slide, children. On solving this, you get x plus y is equal to plus or minus 10. So that means x plus y is plus 10 or x plus y is minus 10. Or x plus y is minus 10. So call them equation 2 and 3. We should not solve 2 and 3. Solve 1 and 2. Solve 1 and 2, 1 and 3. So see here, I'm solving 1 and 2. I'm solving 1 and 3. And find the two numbers. Please go through the slide, children.
Understood, ma'am.
All right, good. Take a screenshot, children. Done?
Yes, ma'am.
Yes, ma'am.
If you understand. Hitesh,
Yes,
Meera,
ma'am.
Deepika, any doubts?
Yes,
Kanishka,
ma'am.
Murali Krishna, Nandini, Pranav, Priyanka, Ramnathan, Sashmin.
Yes, ma'am. Yes, ma'am. I understand, ma'am.
All of you?
Yes, ma'am.
So what's the identity, children? Tarun, Murali, what's the identity? Which we just saw? X plus y the whole square.
And x square plus 2xy plus y square.
No. Ramnathan, what is the identity which we just used?
X plus y the whole square minus x minus y the whole square is equal to 4x square.
Very good. Very good. X plus y the whole square minus x minus y the whole square is equal to 4xy. Priyanka, do you understand?
Yes, ma'am.
You sure?
Yes, ma'am, but I just need to go through it one more time, ma'am.
Yes, yes. No. Constructing the equations. Do you understand that?
Yes, ma'am.
No, you go through now, Priyanka. You go through now. I'll wait for you. You have any doubts in solving the equation, Priyanka? Solving these equations?
No, ma'am.
You know how to solve equations, right? And find the values
ma'am.
of x and substitute
Yes,
in one of the equations to find the value of y. That is fine.
Yes, ma'am.
Okay, then this is what you need to understand. How to construct the equations. Difference of the two numbers is 4. So greater number minus smaller number is 4. Difference of the reciprocals is 4 by 21. So since x is the larger number, 1 by x is smaller than 1 by y. So write the greater number first. 1 by y will be greater than 1 by x. So 1 by y minus 1 by x. Difference of the reciprocals. The greater one minus the smaller one is equal to 4 by 21. Y and x, common denominator xy. So in the numerator, you will get x minus y. The value of x minus y is 4. X minus y is equal to 4. So instead of x minus y, use 4. So you'll get 4 by xy is equal to 4 by 21. You can cancel 4. And when you cross multiply, you will get, this is 1 here, there's 1 here. So xy is equal to 21. Now we know the value of x minus y and we know the value of xy. So we want to find the value of x plus y. Or in fact, you can find the value of x plus y using this identity. Because you know the value of x minus y and you know the value of xy. So you can find the value of x plus y. The three expressions here are x plus y, x minus y, and xy. If you know the values of any two of them, any two, you can find the third one. If you know the values of any two of them, any two, supposing you know, now here you know the value of x minus y and xy. So you can find the value of x plus y. X plus y. After this, we just have to solve the equations and find the two numbers x and y. So as I was telling you, whenever it is, difference, whenever you have this word difference in the question, be specific in the assumption. Let the larger number be x. Let the smaller number be y. Even otherwise, you can be specific. You have to be specific when there is, this term difference in the question. So let the greater number be x. Let the smaller number be y. The sum of two numbers is 1000. The sum of two numbers is 1000. The difference between their squares is 2,56,000. So the two numbers are x and y. The larger number is x, the smaller number is y. The difference between their squares, the square of x is x square. The square of y is y square. The difference of their squares. The square of x is x square. The square of y is y square. The difference between their squares. Difference means minus. The difference between their squares. So that means x square minus y square. X square minus y square. Now x square minus y square means x plus y into x minus y. But you know the value of x plus y. So 1000 into x minus y is 2,56,000. So x minus y is equal to 2,56,000 divided by 1000. This 1000 comes for division to the other side. This 1000 which is in multiplication will come for division to the other side. 3 zeros gets cancelled. X minus y is equal to 256. Now you will have to solve the two equations. X plus y is equal to 1000. X minus y is equal to 256. We need to solve these equations and find the values of x and y. Please go through the slide, children. Go through and ask me your questions, your doubts, if any.
Understood, ma'am.
Very good. Harni, you've sent your assignment on trigonometry, but the last page you're still to complete, or you forgot to take a picture?
Ma'am, I can't understand.
Your assignment on trigonometry, I just went through.
Yes, ma'am.
The last part you have not completed, or maybe you've forgotten to take a picture.
Okay, ma'am, I'll check.
No problem. You would have finished, I know. Might have forgotten to take the picture.
Yes, ma'am.
Any questions, children?
No.
Okay. Yeah. If 3 times the larger of the two, yes.
Ma'am, I have seen, ma'am. I have forgot to take the picture and send, ma'am.
Yeah, no problem.
Can I
I
send it?
know you would have completed it. No, I don't want it. You would have finished it, I know.
Yes,
You don't
ma'am.
have to send, yeah. Yes, children. If 3 times the larger of the two numbers is divided by the smaller one, we get 4 as the quotient and 3 as a remainder. So here to construct the equations, we have to use the division algorithm. To construct the equation, we have to use the division algorithm. We all know that the dividend is equal to divisor into quotient plus the remainder. We all know this. Okay, so now we have to find two numbers. So let the larger number be x, let the larger number be x, let the smaller number be y. I'm reading the question from the beginning. If 3 times the larger of the two numbers, see there are two numbers, we have to find those two numbers. And since the word larger, smaller is used in the question, we'll be specific in the assumption. Let the larger number be x, let the smaller number be y. Now, what does the question say? What is the information given? If 3 times the larger of the two numbers, 3 times the larger of the two numbers, 3x, is divided by the smaller one, smaller one is y. We get 4 is the quotient is 4, and the remainder is 3. Clearly, this is the dividend. What is in the numerator is the dividend. This is the divisor. Oh, it's given there. 3 times the larger of the two numbers is divided by the smaller one. See, now when I say 24 is divided by 8, 24 is divided by 8. 24 is divided by 8. So 24 is the dividend. 8 is the divisor. Three times the larger of the two numbers. 3x, 3 times the larger number, 3x, is divided by the smaller one, y. So that means you will write like this, 3x divided by y, like this. So this is the dividend, this is the divisor. That's how we write. If we have 125 divided by, say, like 15, how will you write that? You'll write 125 here and 15 here. So the numerator is the dividend, the denominator is the divisor. So dividend is equal to divisor into quotient plus remainder. So if 3 times the larger of the two numbers is divided by the smaller one, we get 4 as the quotient and 3 as the remainder. So substitute dividend is 3x is equal to divisor is y into quotient is 4 and the remainder is 3. So the equation is 3x is equal to 4y plus 3 or 3x minus 4y is equal to 3 is the first equation. The second part is if 7 times the smaller number is divided by the larger one, we have called the larger number as x and the smaller number is y. All right. If 7 times the smaller number, 7 times the smaller number, 7y, is divided by the larger one, x. 7 times the smaller number, 7y, is divided by the larger number. So that means here, this is the dividend, this is the divisor. Then we get 5 as the quotient, 5 is the quotient, and 1 as the remainder. So this is the dividend, this is the divisor, quotient, remainder. Fill it in the division algorithm, get the second equation, solve the two equations, and find the values of x and y. So in the first case, it's 3x by y. 3 times the larger number is divided by the smaller one. So the numerator is the dividend, the denominator is the divisor. In the second case, 7 times the smaller number, 7y, is divided by the larger one, x. So 7y is the dividend, x is the divisor. And then you know to substitute the quotient and remainder directly given. Is it difficult, children, or easy to understand?
Easy only, ma'am.
Any questions, children?
No, ma'am.
Sure, all of you? No doubts?
Yes, ma'am.
Priyanka, since you're new to the class, I have to ask you.
Yes,
Any
ma'am.
doubts? Yeah, do you follow
No, ma'am.
Priyanka?
Yes, ma'am.
All right. Take a screenshot, children. Okay. A 2-digit number. Be careful. Here, it was about 2 different numbers. 2 different numbers. See, the numbers are 25 and 18. The numbers are 25 and 18. Here, the question is about 2 different numbers. Larger number, smaller number. 2 different numbers. 2 different numbers. But here it is about 1 number. Find the number. It's about 1 number. A 2-digit number, 1 number, which has 2 digits. So it can be 10, 11, anything from 10 to 99. The answer is anything from 10 to 99. No, I'm just telling you the 2-digit numbers. 10, 11, 12, 13, 14, 15 till 99. A 2-digit number. So it is only 1 number which has 2 digits. It's only 1 number which has 2 digits. The digit in the units place, the digit in the tens place. Now here, you cannot say, let the tens digit be greater or let the units digit be greater. You cannot say that. because the number itself will be, when you're talking about two different numbers, when it's about two different numbers, you can say let the greater number be X, let the smaller number be Y. When it's about two different numbers, you can say let the larger number be X, let the smaller number be Y. But when it's about one number, you cannot say let the tens digit be greater. You cannot say let the tens digit be greater and let that be X. Let the units digit be the smaller one and let that be Y. You cannot say that. You cannot say that. So you don't know which digit is greater. When it's about one number, see, the number, the digits can be 2 and 5. When the digits are 2 and 5, the number can be 25 or 52. Completely different. When the digits, say that two digits are 2 and 5. If the digits are 2 and 5, the number can be 25 or 52. But here, you know, when there are two different numbers, you will get these two only as the answer, 25, 18. If you call X as the greater number, you will get X as 25 and Y as 18. If you call Y as the greater number, you will get X as 18 and Y as 25. That's all. But the two numbers will be the same. You will not. You cannot get when you say, like in this case, you're saying let X be the greater number. Here, Y is the greater number. So if you say X is the greater number, you will get X as 25 and Y as 18. If you say Y is the greater number, you'll get Y as 25 and X as 18. But in any case, you'll get only these two answers, 25 and 18. You will not get two different answers. But here, when the digits are 2 and 5, the number can be 25 or 52. What I'm trying to say is, when it's about one number, you cannot say let the tens digit be greater or the units digit be greater. You will have to take both the cases. So you can only say let the units digit be X, let the tens digit be Y. Or you can say let the units digit be Y, let the tens digit be X. Whatever. Anything. You can assume any one of the two. One's tens, X, Y. Or you can say one's tens, Y and X. So in this case, the number is 10X plus Y. In this case, the number is 10Y plus X. Because if it's 58, how do you write it in the expanded form? 10 into 5 plus 8. How do you write numbers in the expanded form? How do you write 5,768 in the expanded form? 5 into 1,000, because it's in thousands place, plus 7 into 100, because 7 is in the hundreds place, plus 6 into 10, because 6 is in the tens place, plus 8 into 1, because 8 is in the ones place. Digit 5 in the thousands place, digit 7 hundreds place, digit 6 tens place, digit 8 ones place. So we multiply the digit with the respective place value. We multiply the digits with the respective place value. Place value 1,000, place value 100, 10, 1, meaning tens and ones. 5 into 1,000 plus 7 into 100 plus 6 into 10 plus 8 into 1. Similarly, ones, tens, x, y, x into 10 plus y into 1. X into 10 plus y into 1. X into 10 plus y into 1. That means 10x plus y. Okay. So a two-digit number. So if we assume supposing we take this assumption, xy, the number is 10x plus y. The digits are x and y. The tens digit is x. The units digit is y. The number is 10x plus y. Because 10 into x plus 1 into y is y. The tens digit is x. The units digit is y. The number is 10x plus y. 10 into x, 10x plus 1 into y, which is y. A two-digit number. That means, see, as I read, I'll write. See now, a two-digit number, which is the number? This is the number. This one is the number. A two-digit number. So that means 10x plus y. A two-digit number. I'm writing now. I'm reading. I'm just writing. I'm constructing the equation. As I read the question, or as I read the information given, I'm constructing the equation. A two-digit number, 10x plus y, is obtained either by multiplying the sum of the digits by 8. Sum of the digits, either by multiplying the sum of the digits by 8 and adding 1. I'll write it again. I'll write the same thing again. A two-digit number. This one is a two-digit number. A two-digit number is obtained, meaning is got equal to either by multiplying the sum of the digits. What are the digits? X is one digit, y is the other digit. The sum of the digits. X is one digit, y is the other digit. Sum of the digits. Multiplying the sum of the digits is multiplied by 8. And adding 1. So from this, what is the equation? 10x plus y is equal to 8x plus 8y plus 1. So I'm taking, the x and y terms to the other side. You will get this is equal to 1. So 10x minus 8x is 2x. Plus y minus 8y is minus 7y is equal to 1. Is the first equation. Or you can get the same two-digit number, or you can get the same number. See, it's like a two-digit number can be got like this, or the same two-digit number can be got by multiplying the difference of the digits by 13. See here, the second part. This is either by multiplying the sum of the digits by 8 and adding 1. You can get the two-digit number like this, or you can get it in a different way. You can get the same two-digit number in a different way. How? By multiplying the difference of the digits by 13 and adding 2. You can get the two-digit number in two different ways. First method we already saw. Now the second method.
Ma'am?
Yeah, sorry, children. So the same two-digit number can be got by multiplying the difference of the digits by 13. By multiplying the difference of the digits by 13. Difference of the digits now we don't know. In 25, 5 is greater. In 52, 5, this 5 here, 5 is in the units place here, here it's in the tens place. In 25, the ones place or the ones digit is greater. In 52, the tens digit is greater. Now this number which is 10x plus y, where x is the tens digit and y is the units digit, you do not know which digit is greater. You do not know if x is greater or y is greater. So you will have to take both the cases. So if this digit is greater, if x is greater, then it will be x minus y. If y is greater, it will be y minus x. So the two-digit number, see here. So the two-digit number 10x plus y, the two-digit number 10x plus y can be obtained by multiplying the difference of the digits. Difference of the digits can be x minus y or y minus x, depending which digit is greater. So if this digit is greater, that is the tens digit is greater, then it's x minus y. If the units digit is greater, then it will be y minus x. Digits means x and y. See, very simple. Digits are x and y. The number is 10x plus y. If it's number, you must say 10x plus y. If it's about the digits, you should say x and y. If the tens digit is greater, x minus y. If the units digit is greater, y minus x. So multiplying the difference of the digits by 13, multiplying the difference of the digits by 13 and adding 2. So like we did the earlier one, here also open the bracket and you'll get equation 2 and 3. But equation 2 and 3 are constructed from the same information. So you should not solve 2 and 3. You should not solve 2 and 3. You must solve 1 and 2, 1 and 3. 2 and 3 we have constructed from the same information. You should not solve 2 and 3. Solve 1 and 2, 1 and 3. The two-digit number 10x plus y can be got in two different ways. We'll do it again. The two-digit number can be got by multiplying the sum of the digits by 8 and adding 1. Or you can also get it by multiplying the difference of the digits by 13 and adding 2. So according to this assumption, let the tens digit be x, let the ones digit or the units digit be y. So the number is 10x plus y. The two-digit number 10x plus y can be is obtained. Sum of the digits x plus y multiplied by 8 and then adding 1. So this is the first equation. Or the same two-digit number can be got by multiplying the difference of the digits by 13. So difference of the digits can be x minus y or y minus x. Difference is multiplied by 13 and adding 2 and adding 2. Like this, you can get the 2-digit number. So this is equation 2, equation 3, solve and find the number. So you will get x, basically you will get x and y. You will get x and y. Once you get x and y, put it in this. Like supposing x is, for example, 2 and y is 7. So the number is 10 into 2 plus 7, 27. You will get x and y. To find the number, use 10x plus y. Exactly what I've explained, children. So now what happens here, you can see as you work, what happens is, see when you're solving 1 and 2, when you're solving 1 and 2, you get y is 2 by 137. What is y? Y is a digit. Okay, here I've assumed y is a 10th digit. Now don't ask me. Anything can be x and y, I told you. So I have taken the 10th digit as y and the units digit as x. Okay, anything. Now the 10th digit y, this digit is a fraction. We know that we know that a digit cannot be a fraction. Digit in a number, a digit cannot be a fraction. A digit cannot be negative. The number can be negative. The digit cannot be negative. So these two you cannot, these two, that is when you get the value of a digit as negative or the value of a digit as a fraction, they're not admissible. You cannot accept those values. If you're getting a negative value for a digit or a fraction for a digit, you cannot accept those values. I hope I'm clear. So y is not a number. Y is the 10th digit of this number, and a digit cannot be negative. I'm sorry, a digit cannot be a fraction. So that means ignore this case. Ignore this. This is not possible. So ignore this. So on when you solve 1 and 2, you're getting y as a fraction. So ignore this. So solve 1 and 3. See, yes, don't find the value of x. There is no use finding the value of x. We got y. Don't find x. Leave this. So solving 1 and 2, you got y as a fraction. So leave it there. Now take 1 and 3. Take equations 1 and 3. 1 and 3 and solve them. 1 and 3 and solve them. You get y as 4 and x as 1. So the 2-digit number is 10y plus x. In this case, it's 10y plus x. So 10 into 4, y is 4. 10 into 4 plus 1, 41 is the number. 41 is the number. Here I've taken the units digit as x and 10th digit as y. So the number is 10y plus x. 10 into y plus x. Take a screenshot, children. The rough column, you can just write this if you want. Units, tens, y, x, like this. Take a picture, children. Yes, your questions, please. Any doubts? Hitesh. You understand, Hitesh? Meera, understood?
Yes, ma'am.
Sashmin, is it clear?
Yes, ma'am.
Okay. Take a screenshot, children. Yeah. Now I want you to go through this and you can volunteer to explain. You can volunteer to explain. Read the question. You can see the solution also. I'll just be back, children. Yes, who's ready to explain? Tanishka? Are you there, Kanishka?
Yes, ma'am.
Yeah. Tell me.
Ma'am, they have given the. Ma'am, can I?
Yes, yes. I'm listening to you. Yes.
Ma'am, they have given the unit digit as X, ma'am,
Okay.
and the tens digit as Y. So the original number will be multiplied with the value, ma'am, like 10. So tens digit, no. So we have multiplied by 10 into Y, ma'am,
Okay.
and 1 into X, ma'am.
Okay, correct.
That gives us the original number, ma'am.
Okay.
And when we interchange, we will get the value as 10x plus y, ma'am. Like 10 will be multiplied to x, and 1 will be multiplied to y, ma'am.
What is interchanged?
The unit digits have been interchanged, ma'am.
The digits are interchanged. You cannot interchange the place values. We
Yes, ma'am.
cannot write units here and tens here. The place values cannot be interchanged. The digits are interchanged. So according to our assumption, y is the tens digit. That becomes a units digit. And x is the units digit. That becomes a tens digit. So when the digits are interchanged, yes, you're right, Kanishka. Go ahead.
Then they have given the sum in the first like originals number. Some of the numbers will be given as 12, ma'am. Has been given.
Some of the numbers,
Some of the digits, sorry, ma'am.
some of the digits. The
Yes,
sum
ma'am.
of the digits of a two-digit number. It's a two-digit number. But what is 12? The sum of the digits is 12. So which are the digits? X and Y are the digits. Even if you exchange the digits are X and Y. So sum of the digits is 12. That means the units digit plus the tens digit is 12. So X plus Y is 12. Yes, Kanishka, next.
And in the question, they have given that the obtained number is the new number exceeds the original number by 18, ma'am. So the new number minus the original number will give us the value 18, ma'am.
Okay. So the new number
So
is
10x plus.
Yeah.
So the new value, number is 10x plus y, ma'am. Minus of the original number, which is 10y plus x, ma'am.
Is equal to 18. Very good. Okay, thank you, Kanishka. So children, these are the equations. X plus y is equal to 12. The sum of the digits are x and y. The digits are x and y. So sum of the digits meaning x plus y is equal to 12. The number obtained by interchanging its digits. This is the new number which is got by interchanging the digits. This is the new number. There are two numbers. This is the original number. This is the new number. This is the expression for the original number. This is the expression for the new number. The number obtained by interchanging its digits. So this new number exceeds, meaning this is more. This one exceeds. That means this one is more than this one. So whichever number is greater, the greater number minus the smaller number is equal to 18. The number obtained by interchanging its digits. That means this is the new number. Exceeds, meaning this new number is more. The new number exceeds the given number by 18. The new number is more. So new number minus original number is equal to 18. This is the new number. This is the original number, 18. You'll get two equations, solve the two equations and find the values of x and y. And the original number, find the number meaning, find the original number. Find the number meaning, find the original number, 10y plus x. 10y plus x. So 10 into 5 plus 7. So the original number is 57. All right, children? Take a screenshot. Take a picture, children.
Took, ma'am.
So this also you can understand. The only thing is, it's given if the digits differ by 3. If the digits differ by 3, meaning the we have two equations, because you do not know, you cannot assume let the greater digit be x, the smaller digit be y. You cannot do that assumption. If you have to find two different numbers, then you can say let the greater number be x, let the smaller number be y. But if you have to find one number, only one number, and the information is about the digits of the number, you should not assume the greater digit as x, smaller digit as y. No, you cannot do that. So the digits differ by 3. The digits differ by 3, meaning x minus y can be 3 or y minus x is 3, depending whichever digit is greater. Here, the sum of a 2-digit number and the number obtained by reversing the order of its digits is 99. So you know how to construct that equation. The original number plus the new number is equal to 99. You know that. Original number minus, plus the sum of the sum, meaning you'll have to add sum. So see here, sum. The sum of a 2-digit number, that means the original number, and the number obtained by reversing the order of its digits. That means that's a new number. By reversing the order of the digits, you get a new number. The sum is 99, meaning equal to 99. Original number plus the new number is equal to 99. That's what is this. This one from here to here. The sum meaning add. The sum meaning you should add. 2-digit number. The sum of a 2-digit number. The original number. The 2-digit number is original number. And so you're adding the original number and the number obtained by reversing the order of its digits. So the number obtained by reversing the order of the digits is the new number. So the sum of the original number and the new number is 99, is equal to 99. So this is the first equation. This is the first equation. Then the second information is the digits differ by 3. The digits differ by 3. So digits differ by 3 can be x minus y is equal to 3 or y minus x is equal to 3. The digits differ by 3 can be this or this. And we know that these two are equations obtained from the same information. So we should not solve equations 2 and 3. Solve 1 and 2, solve 1 and 2, 1 and 3. Don't solve 2 and 3. Solve 1 and 2, 1 and 3. So when we solve 1 and 2, when we solve equation 1 and 2, we get the original number. See, we get x is 6 and y is 3. So the original number, where's the original number? 10y plus x. 10y plus x is 36. When you solve 1 and 3, when you solve 1 and 3, you get y as 6 and x as 3. You have to find the original number only in both the cases. You have to find the original number. And the original number is 10y. Original number is 10y plus x, 10y plus x, 10 into y, which is 6, plus x3, 63. So the number is either 36 or 63. The number of, that is, both the answers will satisfy. Both these answers will satisfy this information. Will satisfy the information given here. See here, the difference of the digits is 3. Yeah, in 36, the difference of the digits is 3. In 63 also, the difference of the digits is 3. And the sum of the original number and the new number is 99. The sum of the original number and the new number is 99. So the number can be 36 or 63. The number can be 36 or 63. Take a picture, children. Yeah. So what is given here? Seven times a two-digit number. 7 times a two-digit number. The two-digit number is 10x plus y. 7 times, so into 7. 7 times a two-digit number is equal to 4 times the number obtained by reversing the order of the digits. So the new number, once tens, y comes here, x comes here, 10y plus x is the new number. 4 times the new number. See, the number obtained by reversing the order of the digits is a new number. The number obtained by reversing the order of the digits is a new number. So 10y plus x. See, by now we know this assumption. Once tens, supposing you say x and y, then the original number is 10y plus x. So the number formed by reversing the digits, x and y here, will be 10x plus y. This is the original number, supposing we assume like this. This is the new number. 7 times a two-digit number. So 7 times a two-digit number is equal to 4 times the number obtained by reversing the order of the digits. That is a new number. 4 times the new number. If the difference between the digits is 3, so again, we don't know. So it can be x minus y is equal to 3 or y minus x is equal to 3. The difference between the digits can be x minus y or y minus x is equal to 3. So from this, you get one equation. Here. So these assumptions, units digit. So here I've taken like this, units tens is y, units is x. Here, x, y like this. It's important to write this. I didn't make this, but it's in the rough work, or you can just do this beside this itself. Beside this, you can just tens. So here it is like this. Yeah. Yeah. So 7 times the original number is 4 times the new number. I've written in short. In short, I've written 7 times original number. That's what is given is equal to 4 times new number. So 7 times. You understand this? I told you many times. So I think you got this. So when you open the brackets and work that, you get this equation. X minus 2y is equal to 0. You get this equation, x minus 2y is equal to 0. See here, this is what we actually get. You can divide by 33 throughout. 33 or minus 33. That's what is taking common. I've taken minus 33 common. Minus 33 into x is minus 33x. Minus 33 into minus 2y is plus 66y. Taking out the HCF. And then what will happen to this minus 33? It will come to the other side for division by minus 33. So it becomes 0. X minus 2y is equal to 0. You're simplifying the equation. You're simplifying the equation. See, this is what you get. Between these two terms, you can even take out 33 common. Not that you should take minus 33. You can also take 33 common. I've taken minus 33. You can even take 33 common. But if you take 33 common, you will get minus x plus 2y is equal to 0, because 33 into minus x is minus 33x. See here, this is what you should get. If you take 33 common, you must write minus x, because 33 into minus x is minus 33x. Then you should write plus 2y, because 33 into 2 is 66, 66y, and plus, because plus into plus is plus. The signs will change. You can take out even 33 common. 33 common, you will get minus x plus 2y is equal to 0. Then this 33 will come for division. Minus x plus 2y is equal to 0 by 33. Somebody is sleeping. Minus x plus 2y is equal to 0. All right. This 33 comes for division. 0 by 33 is 0. So same thing here also. I've taken minus 33 common. That comes for division here. 0 by minus 33, which is 0. So that's the first equation, and a difference between the digits is 3. So I told you it can be x minus y is equal to 3 or y minus x is equal to 3. Yeah, you should not solve 2 and 3. Solve 1 and 2, 1 and 3. What happens? Please listen, important. So when you solve 1 and 2, please listen. When you solve 1 and 2, you should not solve 2 and 3, children. Their equations got from the same information. Don't solve 2 and 3. 1 and 3, when you solve, sorry, 1 and 2, when you solve 1 and 2, we get y is 3, we get x is 6. And so the original number is 10y plus x, which is 36. When you solve 1 and 3, what happens when you solve 1 and 3? We get y is minus 3. A digit cannot be negative. A digit cannot be negative. So that's all. Don't proceed. Ignore this. So the original number is 36. Done. That's it. The original number, only one answer here. The original number is 36. Only one answer here. We can get two answers, but when we solve equations 1 and 3, we get y is minus 3. Y is the digit in the tens place, and it cannot be negative. A digit cannot be negative. I told you earlier. A digit of a number cannot be a fraction. It cannot be negative. It cannot be a fraction. It cannot be negative. So y is equal to minus 3. Digit is negative. Tens digit is negative. No, it cannot be. So ignore this. Ignore this. Don't strike it out. I'm just telling you, just ignore this. So the original number is 36. The original number is 36. Only one answer. The original number is 36. Take a screenshot, children. So you saw two cases. One where the digit is a fraction. So you ignore that. And here where, digit is negative. So again, you ignore that. Take a screenshot. Yeah. You can help this. I'm sorry, you can help yourself with this one. Take a screenshot. When I say you can help yourself with this one, I mean it. Meaning, it is definitely simple because we have seen a case earlier where, we get one linear equation on x and y, and we get another equation like this. We have seen a situation like this earlier. Yeah, so we have seen a situation like this earlier, and you know how to proceed. When you have one linear equation in x and y and another equation like this, I've told you we need to use this, formula, algebraic identity. We need to use this algebraic identity. So here, I have not written x plus y is equal to plus or minus 9. Because x and y are the digits of a number. And the sum of the digits cannot be negative. You cannot have a situation like x plus y is equal to minus 9. Why? Because x is the digit in the units place. Y is the digit in the tens place. X and y are the digits in the units and tens place respectively. The sum, see, the number is 256. When you find the sum of the digits, they will be positive. The sum of the digits cannot be negative. Please think about that. The sum of the digits cannot be negative. Now see here, x plus y the whole square is equal to 81. So x plus y is equal to actually plus or minus 9. So x plus y is equal to 9 or x plus y is equal to minus 9. But when you just think about this equation, x plus y is equal to minus 9, it means the sum of the units digit and the sum of the the sum of the units digit and the tens digit is minus 9. That's not possible. The sum of the digits of a number cannot be negative. So we take only this case. X plus y is equal to 9. We take only the positive value. We ignore the negative value. Because in this situation, where x and y are the digits of a number, their sum cannot be negative. So x plus y is equal to minus 9, we'll ignore. We'll not take the situation. We'll take only x plus y is equal to plus 9 because only that is possible. So you'll get only two equations, 1 and 2. Solve and find the number. Take a screenshot, children. Done?
Yes, ma'am.
Class, use the emoji. Raise your hand. Priyanka, are you there?
Yes, ma'am. Ma'am, the hand raise option is not working, ma'am. I'm trying.
Okay. So at the end of the meeting, we have Priyanka, Tarun E, Murali Krishna, Ramanathan, Sneha, Harini, Kanishka, Kashmir, Tarun Murali, and Nandini. Yes?
Ma'am, I am also there, Pranav.
Okay, Pranav. All right. All right, children. So that's it for today's class. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children. Good night.
Thank you.
Thank you, children. Good night.